Hey there, everyone. Welcome to this Learn Live session for Ignite. I'm Jason DeBoover. I'm one of your hosts. And with me is David Blank-Edelman, your other host. Hey, David.
Hey there. I'm so happy to be here. I cannot begin to tell you, Jason.
I think we're starting like 90 seconds early. That's super cool. That means we get 90 extra seconds to talk to everyone.
Oh, cool. Hi, everyone.
So, David, can you tell us a little bit about
I was going to say happy Diwali for those people celebrating it tomorrow, you know, stuff like that.
So I'm Jason DeBoover. I don't see our. I want to see our slide so I can show everyone our barcode there. There it is. All right, thank you. Now we can share that barcode. So, folks, we are going to be kind of following along with a Learn module like we do for all these Learn Live sessions. And if you scan that barcode or if you use that AKA link right there, you're going to be able to pull up the Learn module and follow along with us. As a matter of fact, there's the snapshot of the Learn module right there. We do have a bit of a special treat today, I like to think, because you're seeing a sneak preview of what the Learn module will look like, and a sneak preview really of what we're doing lately, what's most up to date in terms of well-architected. So we're going to be looking at the newest things with the well-architected review, the well-architected assessment. And like I said, the pillars, the format of our Learn module has changed a little bit. So like I said, scan that link right there, the barcode right there, or add that aka.ms into your URL, and that's going to take you right to the Learn module. Of course, maybe you want to do that later because you really want to focus in on what David and I are saying right now, but you can follow along if you want to. So David, do you want to tell us a little bit about what we're going to be learning today?
I do, and then we should at some point probably tell other people why they should listen to us and like who we are, it occurs to me.
Ooh, good point.
So let's do that when we hit the introduction slide, but let's talk about why people are here today. So my fond hope, and I think Jason's fond hope when we're done with this, is that by the time we're done with this, you're going to get a chance to understand what this weird thing we're calling the Azure Well-Architected Framework is and why it's going to be super useful to you to know about and to peek at. And we're only going to sort of like skim the surface of many of the things in there. But we're hoping you're going to be so excited about this stuff, you're going to want to go learn more. You're going to want to go dig into our docs and stuff like that. And the thing that we're going to try very hard to do in this, which is one of the things that's where we're going to insert some stuff in that's not in the module, is we're going to show you how you can sort of engage with the things that are in the well-architected framework in your organization, with your workloads, your actual stuff, instead of talking sort of on a very theoretical level, which sometimes the docs can do. But this will be how do you engage directly. And when we're done, we hope that you'll have a sense of sort of some of the principles that are associated with, good architecture. And when we talk about that, why we hear about that, we'll talk about that when we actually get into what is the well-architected framework. Or sometimes you'll hear Jason and I use the term WAF, just the acronym. Please excuse us if we do that. It's just a lot easier to say than Azure Well-Architected. Oh, but the cool thing about this particular session is, Jason,
we're live and we're interactive, right? That means we're actually talking to you right now. That's why occasionally I might say something like, hey, look at that slide, or I want to see the slide. Or David might say to me, let's move that slide. These are the things that happen with live shows. So we're live, but what that does mean for you is you get to ask us questions directly. So jump in the chat window. We've got some moderators there working with us, and they'll answer the vast majority of questions, but every now and then they'll think one's interesting in a way that it might be fun to throw it at Jason or David and see what we do with it. So definitely make it interesting in the chat. Keep it busy in the chat. You'll get your questions answered, and it'll just be engaging, entertaining for everyone. And we'll even handle a few of those questions live on the broadcast here.
And we know this is there's a lot of cool stuff to talk about here. The other thing to just let you know, just so you know the human part of this, Jason's driving the slides, and I'm a passenger like you are. So you'll see that happen. I'm just the chatty passenger who's like pointing his finger out the window and going, "Oh look, there's the Ball of Twine, museum. That was founded in 1930, and maybe you should stop there," or whatever it is that's interesting that we're going to talk about.
So I will stop at the Ball of Twine Museum. Make no mistake. We will definitely be stopping there. All right, let's introduction. Let's use that slide for the introduction of ourselves. So I'm Jason DeBoover. Like I said, you're David Blank-Edelman, but I want to hear about you.
Gosh, well, you know, I like long walks on the beach. I'm a Virgo, but maybe that's not what you're asking.
Might not be the
I'm
most
a
important
cloud
thing
advocate
today.
here. Yeah, I'm a cloud advocate here at Microsoft. I spend a lot of time thinking about site reliability engineering and other modern operations practices. I'm located in Boston, and I understand there's a lot of people in the chat telling us where they're from, and it's really awesome to see all these different places. Like, that's exciting. This is sort of a global thing, so I'm really digging that.
Yeah, I love having the entire globe covered by these things. It's really amazing.
Yeah, it's totally blessed. So Jason, talk about you.
So I'm a senior product manager here at Microsoft. I focus mostly on our ML content, which you might be wondering, well, if we're talking well-architected today, what's that got to do with ML content? And you'll see. It's actually one of our cool new things that we're going to be talking about today with regard to our well-architected assessment.
Yeah. Okay, well, let's do it.
All right. What is well-architected? You gave some hints earlier.
Yeah,
The Azure Well-Architected Framework will help you to design, build, and continuously improve a secure, reliable, and efficient application.
We probably could have gotten a voice modulator to do that for you.
I'm sorry, I should have. I really should have. What I guess what I just want to say is it's meant to be a set of guiding principles. It's meant to be a set of practices and things that you can use to get you to where you want to be around your workloads. And that's kind of the key thing here.
I like to think of it as kind of pointers, because our docs can just be so overwhelming. Even our Learn modules and our Architecture Center can be so overwhelming if you were trying to kind of start from a beginning and say, how do I know that I'm doing things right? And so I like to think of it as a nice guided tour and a set of pointers to the appropriate places, sort of make the unknown unknowns known unknowns.
Yeah, totally. And we'll go to stuff that will also help with, like, where do you go next? Like, there's definitely gonna be some where do you go next in this talk for sure.
Where do we go first?
I think we should go, strange enough, to the pillars. This is what I like to refer to as the cloud is good slide.
Cloud is good. I like it.
Yeah, we don't have to say anything about that. So that was our exciting slide. If you want, we can go back and say why cloud is good, but presumably you know.
Because it has a parachute?
Yeah, I don't really understand that either. So, well, anyways, so enough about that slide. This slide, what we want to talk about here is the Azure Well-Architected Framework is broken down into a bunch of tenants, or we call them pillars, right? These are subjects or items or aspects that we anticipate that you are going to want to participate in, to look at, to examine, to talk about in your organization. And those particular pillars in this particular case are written as reliability, security, cost optimization, operational excellence, and performance excellence, efficiency. And the thing that I want to point out about these pillars, in addition, and we're going to go into depth into all of them, is the order that you see here is different than the order in the module as it stands. And that's because our experience is this is like one of those wheels where you spin the wheel and you come to a different item. It goes tick, 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 tick until it stops. And sometimes for you, it stops at security. Sometimes for you, it stops at reliability. Sometimes it's something else. Our experience is that you will get a knock on the door from each of these pillars when, you know, at some point in time, you may be paying a lot of time, a lot of energy looking at the security of your application right now. But at some point, you're going to probably be thinking a little bit more around cost, or maybe that's the place you start. And so we just want to say the order here does not represent the order we expect people to go through or pay attention. You will find your own, I promise you, or it will find you.
Yeah, like I think an example you've used in the past that I love is you might be focused on, you know, operational excellence and performance, and then you get a knock on the door from the CFO saying, "I just got this bill."
Right,
So
and then you're off to the cost
debating.
optimization, right? You know, and that's fine. Like, and the other thing that I want to say about these pillars that's also really interesting is they're not silos in that it's very interesting how they interact with each other. Right? There's a weird relationship in which sometimes it's like a push me, pull you relationship between all these pillars. So you might be paying attention to reliability and you realize in order to do something for reliability, I'm going to have to increase my costs. Not necessarily, you know, badly, but sometimes you might look at something and you might say, oh, well, in order for me to be more efficient, I need a caching layer. And well, that's going to increase my cost. Or maybe if my reliability is bad, then my cost is really high and I should be spending some time working on that. So these interactions, I think, are are really, really, really interesting. We're not going to dig too much into them, but anybody who is in this field knows that they're all playing off of each other all the time, and that to me is really interesting.
Now, that's actually a good lead into my next question for you. You said, anyone who's playing in this field. So who do you think we're targeting here with these messages, with the well-architected framework in general? Is it the greenfield application where there's no one or there's no application actually deployed? Is it a migration? Is it someone who's already in Azure but just wants to do it a little better? Right. Who's the primary target, do you think?
So the good news from my perspective is the well-architected framework is meant to address what you're going to be dealing with at different times in the life cycle of what you're working with, right? So it's going to address stuff when you're first trying to figure out what to do. It's going to address stuff for the people that are already deep into their cloud stuff. It's going to be the people that are Azure curious, however you want to put it. In my aspect, the way I like to think about it is what really throws people off about the term well-architected is it has the word architect. And when we think about architect in there, we think about the person you go to help you design the house. And then you design the house, you go build the house, and then you never see the architect again, or very rarely. You don't knock on your door 2 days later going, hey, built the house, let's architect some more, right? I mean, usually what happens, but that's not the way it works in software, right? Like we're always iterating, we're always redoing, refactoring and stuff like that. So the key thing about the Azure Well-Architected Framework is the goal is to keep your applications in a well-architected state. And these are the ways we're going to do it. And we're going to dive into all those, in the pillars.
Fantastic. So as we start to think about these, what things do we keep in mind sort of in a cross-cutting way that aren't necessarily only belonging to one pillar?
Well, there are things that are true amongst all those. So the first one is this notion that we were just talking about a moment ago, which is software is always changing, right? This enable architectural evolution says if you're not building with the assumption that things are going to change, you're going to be in for a nasty surprise. It's also really important, and I know it's kind of hard to have to say this, but sometimes we make these decisions sort of like out of our gut, like, oh, I think things are pretty reliable. How do you think they're going? I don't know. I think, oh, but no, that wasn't so reliable. You want to use data wherever possible.
I always say you can't be data driven until you have data, and that means trying things. Sometimes you have to try things before you have data in order to get the data to react to.
Yeah, totally true. The other thing that we've also come to the understanding is that people, you would be surprised, but it's really important to spend a lot of time paying attention to what you need to learn. Like one of the things that we find is that there's this, the skilling gap or whatever you want to call it, where the thing that gets in people's way is they're not up on what they need to know to do stuff. And that's not a fault of theirs. It's everything's moving super fast. But and Microsoft does a bunch to try to help with that. There's like lots and lots of resources along those lines. But it's really
they keep both of us on staff to try to help with that.
Yeah. And strangely enough, you seem to be in the midst of a talk in which we're doing exactly that. So we're hoping this helps. And then the last one on the list that I think is common to all these pillars is that automation comes into play. And we're going to talk about automation much more deeply when we get to the operational excellence pillar, because it's one place you could put it in this discussion. We could talk about it all throughout. But this idea that instead of doing things by hand, instead of being very manual about things, you want to see if you can get the computers to do what computers do well. Or as someone I know says, stop feeding blood to the machines, right? Like if it's possible, it's really good to try and see where automation is possible. And we'll talk about why that's not always possible and other good stuff about automation later. So if you're an automation head like I am, stay tuned is what I want to say.
Awesome. So we have a question, and I think the answer to the question is we're going to explain exactly that later. But I just want to kind of reflect it up to you as well, David. Performance efficiency and cost optimization seem to overlap significantly. Does cost optimization also reflect alternatives to create the same performance at a lower cost? And that's from John C. And I think the answer to his question is, do they affect each other? Is absolutely. Yeah. And do they overlap? Absolutely. We'll talk a lot more about those types of overlaps continually as we go.
Yeah, and the more I deal with this stuff, the more I see the cost is weirdly in every one of the other categories. It just comes up because money is a thing, right? And we pay attention to money. The other thing that's also weird about money is we can measure it. Like it's a lot harder to measure reliability. You know, we have measures for reliability, but they're not nearly as clear as like I lost this many, you know, euros, you know, in an outage or so on. So I think we're definitely getting into it. I want to say that one of the things that will be useful to understand is that one of the things that two of them share is that you are trying to shoot for the best value for your effort or your money or your resource, right? And we'll talk about that in detail later. And that's true in both of those. So it's a really cool thing. But I would say to you, John, we could have this conversation and I could pull out cost optimization stuff out of every one of those pillars and you would be nodding your head vigorously, I suspect. I actually can't see you. I don't know if you have a head, but I'm assuming you do, and I'm assuming you would probably be nodding. So, so we have a slide here. Yeah, let's actually get back to the track here. So one of the things that we think it's useful to understand about everything in the well-architected framework is something that we used to call shared responsibility, but I'm more comfortable with the term dual responsibility. And what the idea of dual responsibility says, hey, there are some things that we, Microsoft, the cloud provider, are providing to you, right? We're agreeing to run these services. We are agreeing to make them this reliable, this secure, that sort of stuff, and we'll take care of that. You, on the other hand, are also responsible for certain things in your workload and in your code and whatever you're running that only you can take care of. And we try to provide resources to make that easier, monitoring, other stuff like that. But there's this dual responsibility that sometimes overlaps. And the thing that I liked about something that Jason and I have talked about in the past is you get to move the slider. You get to decide based on what you're choosing to buy, where you want that responsibility. So if you like the control that you get from running your own VMs, you know, infrastructure as a service, that sort of stuff like that, you need that control for some reason, you can slide it to the whatever that direction is for you. If you want Microsoft to take care of stuff, you can slide it all the way to the right, you know, for like Office 365. You're like tired of dealing with spam filters? Well, you know, like we could do that for you, sort of thing. But even then, there's a little more nuance, right? Jason, you were talking to me about O365 as well, right?
Right. And I think, you know, this is a great time. Also, I want to discuss the fact that I think you said earlier we're going to dive deep into all these pillars, and I went like this, and I went,
oh yeah,
we're not going to dive deep. The reality is WAF is so complex. Azure is so complex. WAF is already, well-architected framework is already an abstraction on the complexity that is Azure to try to help us do the right things. We have about an hour to discuss with you that abstraction. So we're going to abstract it even further. And that's why, you know, when we are looking at this slide about infrastructure as a service versus software as a service, something that people do entire talks on these trade-offs as you go along this. We're going to talk about it in about 30 seconds. Well, we're probably up to 90 seconds now, but we're going to have to bring that abstraction up even farther. So it definitely won't be a deep dive. It'll just be deeper than the one slide that David was talking to at the time.
Yeah. Can we hit a question that I just saw come in just briefly, because I know other people probably have it. So there's a question that came in about the well-architected, if I could say it, it'd be even better. The well-architected framework and its relationship to the cloud adoption framework. And it can be very easy to say, like, what's the difference here? Especially because if you say one, it's WAF, the other one you say CAF, and we do that all the time. The way I like to think about the difference between them is I think of the cloud adoption framework, in addition to what it's saying, which is how do you get and adopt and thrive in a cloud, is being sort of an organizational level thing that starts to zoom in as part of it into the workload level to a certain extent. But for me, the WAF starts at the workload and then starts to move its scope outwards. You know, you're pulling the telescope back. Right, you're zooming out with the telescope, and so that's to me what the difference is yeah, same workload, same Azure, right? But the question is, what's your focus and where do you start when you start looking at it? For us, we're going to be starting, you know, workload in and then looking workload out, I guess would be the better way to say it, and then looking there. Cloud adoption framework might be whole organization in and then slowly zooming in, but not quite into the workload level. You know?
In fact, another just more concrete way to even think about it is if you look at the cloud adoption framework and the landing zones principle that they talk about quite a lot of the things in the landing zone are going to either point to or snap to very consistently our well-architected guidance, which is exactly for the same reason.
Yeah, totally.
In a philosophical way.
And you will see some echoes of the WAF in lots of other things that we'll talk about later, like Azure Advisor, like stuff like that shows up all the time. This is our knee slapper slide, right?
We want our architectures to be perfect.
Yeah,
welcome
in an ideal architecture, you build something that's totally secure, high performance, highly available and efficient, and it's the perfect sphere. But like it is the case that reality is reality. And as I was talking about before, these pillars are always interacting with each other. So you have to understand that you're making these choices and these trade-offs like constantly, even if you're not aware of it. And we're hoping to give you some sense of like how that happens. But again, this is going to be surface level, as Jason was clear to point out. And the place that we probably want to start is my favorite place, because I dig the reliability stuff. So you're going to hear me do a lot of the talking on this one. I want to talk about the reliability pillar. So let's start off with the basic question, what's reliability, right? And that's the question that says that in an application, any number of things can go wrong at any scale. And the greater the scale, the more likely it could go wrong, right? And for me, reliability is about meeting expectations. And I want to talk about what kind of expectations, to be specific. And this, we have the super cool PowerPoint diagram that Jason and I are going to try to coordinate between to show you this sort of stuff.
And the one thing I want to even point out before we try to coordinate this is that bringing out what you said, it's about customer expectations. Simply rephrase it in your head as, what is the customer relying on me for? If you can just phrase it that way, you'll realize there's quite a few things.
Yeah, so when I talk about reliability with people, I often start to say reliability can be many things, and there are many aspects. And most people start off with availability. Is it up or is it down, right? And you might spend all your time or most of your time dealing with that. But soon you start to realize that there are other things. For example, latency. How quickly do I get responses back? Because you'll hear people say that slow is the new down, right? and that can be a problem, because if your website is too slow, people will go somewhere else. But if, let's say you're not running a website, let's say you're running some sort of pipeline, and you might care about throughput. Or let's say you're running some sort of batch system. In that particular case, you might care about the next thing, which would be coverage, right? Like, am I doing everything there? Or let's say we're not doing that. Let's say I want to pay attention to correctness. Is my processing doing what I expected to do? Or there's other ones like this one here, which takes a couple of seconds to explain, but I'll be real super quick. Like, let's say you're using something like Netflix, some sort of video streaming place, and you're a customer. I'll admit to being a customer of Netflix. And when you go to their website, you see a very, their page that shows, here are the things here's the new movies, here's the things we recommend you watch, here's the stuff you recently watched, here so you can continue watching. But if they have a problem with one of the little microservices, and there are tons of microservices that power Netflix, like let's say the recommendation engine goes down, if you go there and that one microservice is down, you don't get this big banner that says, sorry, no movies today, come back tomorrow when the recommendation engine works, right? They show it to you in a degraded state. They pull out the recommendations, they put something static there. And that's fidelity, right? That's like, am I giving it to you in its fullness? But if you're running a website that's not like watching movies, maybe you're watching something that cares about sports scores or election results, right? There was recently an election, yesterday in the US, right? And you might care about freshness. Or if you're running a storage system, maybe you care about durability. And so there's lots of aspects, and you can probably think about more, but we want to make sure that the thing that I want to say about this that might be really super useful, maybe the key thing that I'm going to say about reliability in this thing is the next sentence, right? The next sentence that I want to suggest is that reliability is measured from the customer's perspective, not the component perspective. I'll say it one more time. Reliability is measured from the customer's perspective, not the component perspective. And to make sure that I'm driving this message home, I think, Jason, if you're up for it, we should do like this quiz. What do you think?
All right, let's do the poll.
Okay, so let me explain a scenario to everybody here. Congratulations, all many people of you who are currently on, in this session with us, and we're thrilled you're here. Decided what you want to do is go work for a company that makes clouds on tote bags with clouds on them. And in order to do that, you set up a system where you have 100 servers. And yes, indeed, this is actually 100. Feel free to count if you want. I know I personally put them on the slide. Big pain in the butt. But let's say there's a problem at the
David hasn't discovered copy paste yet.
I did. No, these are handcrafted pixel by pixel. You would believe the time we put into this sort of stuff, like with a quill. But let's go back to this scenario if we might, Jason. So imagine something goes wrong at the data center. Imagine a bad software release goes out, or there's a problem with power distribution or something like that, and 14 of your machines burst into flame. Well, maybe not burst into flame, but at least 14 of them are broken. So let's just review this for a moment. 86 are working just fine, 14 are down. Here comes the quiz for everybody. I'm going to lay out the options for the quiz. I'm going to ask you to vote, and then we'll review the poll. And I'm going to ask our kind producer to let us know how the poll is going, because I don't think I can see it immediately in the chat that I've got. So okay, here we go. Here comes the options.
All right. There.
Okay, is the situation 86 up, 14 down? A, no big deal if you're at the beach drinking a fruity drink and with it out of a coconut with a little paper umbrella, you can stay there and just enjoy your time there and maybe put on a little more sunscreen. Or is the situation B, no, it's a problem, I should walk to my desk right now and deal with it? That's the deal. Or is it C, this could be an existential crisis. And if this is happening at 2 a.m., it doesn't matter what time, we're going to scramble all the hands, which means we're going to get the C-level people out of bed because this could be a thing. No, you should go one more so C is visible. Okay, so now it's time to vote. And I don't know, do you want to sing a little song while we wait for people to vote? Or do you want to talk about
how are we at theme songs there?
I don't know. We probably haven't licensed anything.
Yeah, that's what I was just realizing. That's probably not the best choice.
But I'm really hoping that people are voting now, because this turns out to be a little bit of a tricky question. Because and it's good to ask. It's really good to ask people in your environment. Like what I recommend you do with this particular chat thing, what I recommend you do is ask it in your own home environment and see what people say, because this is an easy one to reproduce. Okay.
Yeah, because even if you kind of start to have an instinct about what it should be if you were more architected the way you'd want or whatever, it'd be interesting to get people's reaction in the sense of answer it in light of the architecture you do have and how you think you would approach it the way your situation is now. It looks like the majority of people are going for B right now. We've got folks, actually more than half going for B. So A and C definitely lower.
Okay, so let me tell you what I think the answer to this question is. And strange enough, I have the answer right here on my t-shirt. Yes.
Sorry, folks, we didn't even give you that as an option. Yeah. We wanted to be able to make this point.
yeah. So, and we steer no production expenses, like we even put on our clothes. So back up 1 second let's just talk about this for one second. The reason why it depends. Let me just be clear about this. If none of your customers notice any problems at all with your application or whatever they're using, then it might be A. You can stay on the beach longer, no problem, right? If nobody notices. If B, you're having some sort of a degraded state or things are slow or things aren't working, or you're seeing some stuff there, it might be B. But if you're like hemorrhaging money and you're having a Knightsbridge capital sort of thing where in 45 minutes you lose 3/4 of the worth of your company in high-speed trading, it could very well be C. And so the thing to hammer home here is that the answer here goes back to that question where it says it's measured by the customer, not by the component. So I want you to just understand that's really kind of the key thing. The data was exactly the same. 86 up and 14 down was not wrong. I didn't tell you objectively wrong data. That was exactly correct. But that was at the component level, and it didn't matter. Yep. Is my CPU running at 90%? That could be great. That could be terrible. But so in order to talk about reliability more, we have to get into lots of these words. And this is my little quiz for you, Jason. I'm putting a lot of words on the slide that I think get associated with reliability all the time and get like thrown around willy-nilly. Do you feel like you have a good set? Like, could you pick these out of a crowd, or do you want to like take a couple of seconds to figure out, like what do they specifically mean when it comes to reliability?
Yeah, I mean, well, I think partially for me, it goes back to the question that was asked of us earlier, which is don't these things overlap so much? And for me, I see that they do. I mean, we talked about latency and throughput, right, for instance, in that other slide that you had, and that's those are perf questions, but they're also reliability questions. So same thing here, right? I mean, for me, high availability and fault tolerant, we can start to pull apart the differences, but they also affect each other a lot. So, I mean, we definitely have resiliency in there, which is related, but not exactly the same. So I see the Venn diagrams going like this.
Yeah. Yeah, so let me see if I could tease it slightly out just for other people who don't get it as clearly as you do, because I think that people often say, oh, I want my thing to be reliable, or I want it to be resilient, and they don't really make a difference. They don't have any sort of difference between them. So for me, high availability is a goal, right? You want to make sure things are highly available, and we'll talk about whether that's a good goal or not, but you want to make sure things are highly available. And so you might use fault tolerance as one of the techniques you use to get there. My machine, when it notices a fault, it repairs itself, it restarts something. It retries. There's lots of ways to make things fault tolerant, and that contributes to that. Another way you can make things high available is to have some sort of redundancy. You have two of it, like something breaks, you talk to the other one, or maybe you set up an entire cluster. Maybe it's a geo spread cluster, right? And that gives you that sort of stuff. And then we get into these questions that people also ask, well, reliability is all about recovery, you know, like my disaster recovery, how quickly do I get back to service? And that's an aspect, but it's not all what reliability is. And then for me, resilience is the harder one to talk about, because there is an entire field called resilience engineering. And resilience, we throw it around, but there's really good, there's multiple ways to think about resilience. But one of the ways that I thought was super useful to compare reliability and resilience was something I heard John Allspaw say once at a conference, in which he was talking about, okay, your job is to deliver a package from point A to B, and your car breaks down. So redundancy would be, I have a spare tire. Resilience would be, I know how to rent a new car. I know how to get somebody else to help take the package for me. I understand transportation, right? Resilience is that adaptive capacity to respond, right? And that's to a large extent where I think resilience is a really important word. We need to make sure it doesn't get mixed up with reliability. The other two words that do get put into this pot that I want to make sure we say before we go very much further is that reliability and resilience are all referring to a socio-technical system. Like we usually talk about things as like, oh, the machine went down and the people are responsible. But it's really important to understand that in any sufficiently complex system, the people are also serving a really important role. And sometimes the people are the things that are keeping the system reliable, because they're stepping in and making those changes in an adaptive way that the computers couldn't do.
They're the folks who are resilient or thinking about resilient fallback plans in order to allow the systems to themselves be resilient. Yeah. They're the ones who know how to get back up when they get knocked down. Computers don't know how to do that without us telling them.
Right. Chumbawamba aside, I totally agree with that idea. I guess I just want to say the thing that I understand is often we blame the people, like, you know, like it was human error or pilot error or something like that. And the thing to understand that we're coming to understand about resilience engineering is that the people have a very important role, and we should be paying attention to that role. And the last thing I want to say comes from my background in site reliability engineering, which is we pretty often talk about reliability and high availability as if like, hey, yeah, I should be up 100% of the time, all day, all week, all month, all year. And turns out that for many, many systems, in fact, most systems, you're really looking for the appropriate level of reliability, not 100%. 100% is very rarely the appropriate level. And spending your time to try to get to that place is counterproductive at best, expensive at most, you know, most often, and not worth its while. We could have a whole other conversation, maybe in the chat or later on about that. But I think we probably have to move on at some point, right?
Yeah, for sure. Going back quickly to your Netflix example, Netflix doesn't need their rating system to be 100% reliable, but they sure as heck need their movie streaming system to be nearly 100% reliable. So yeah, they treat those with a different level of prioritization.
Yeah, there are two metrics that they actually watch, having talked to them about it. They watch stream starts and they watch subscriptions, right? And if any one of those deviate off of what they think they scramble the entire company, right? Like when necessary. So like, it's really important. But I feel like we've been talking and I would like to do a little bit of showing. Would you be so kind as to do a demo for us and talk about why we're doing a demo?
So we of course have Well-Architected Framework, which is this set of guidance, and it's a fantastic set of guidance that does a good job of abstracting all of the Azure documentation, all of the Azure guidance into a set of principles. That's what Well-Architected Framework does. However, it's still pretty big. The Well-Architected Framework guidance is still pretty big. So what we have are the Well-Architected reviews. The well-architected review is going to ask you about your specific situation. So you're going to walk through and answer questions about what you're doing in your specific situation, what you're doing with regards to different services, whether you're using certain services, what kind of governance plans you've put in place, what kind of policy engines within Azure or within our other infrastructure you're taking advantage of to enforce that governance. So we have these built-in questions that will then turn into guidance. So if you're not taking advantage of things that you should be, especially given the particular type of workloads that you have, then we're going to be able to tell you exactly what to do given your workloads and what you're doing so far. Additionally, we're also going to be able to integrate with Azure Advisor. Azure Advisor is actually running in the background of your service and is aware of, I should say, running in the background of your service, running in the background of your subscription. So it's aware of all the different services that you're taking advantage of, how they tie together, and what you should be doing to hopefully improve either your security outlook or your performance outlook or your cost outlook. It cares about all those things, as we'll see a little bit later. So what I've done is started a review, and I'm just going to name it my review here real quick. Now, if I wanted to tie into Azure Advisor, I could log in right here, and we're going to actually look at that later. We're going to look at what happens when I log in and have all that stuff tied together in a little while. But for right now, I'm just going to hit start on this one so we can start getting into the questions. First thing it's asking is, am I looking for the core well-architected review or the Azure machine learning review? I'm going to get into that one a little bit later as well. So for right now, let's just start that core review. Sound good, David?
Yeah, I'm totally digging this. I want to say one quick thing that I think is super useful to know about the well-architected review. For me, the thing that's most valuable about the well-architected review is all these pillars, the things we're talking about. You can start anywhere, and often it can be really hard to know what questions you should be asking. Like the key thing about this well-architected review is it's going to show you some of the questions you need to be thinking about. And for me, that's like gold. Like that's the thing. Like I don't know what I don't know, and this is the thing that helps me. You know, your known knowns and your unknown unknowns you were talking about before. I really love that. I think we should show some of those things.
All right, we're going to get into this and look at that, the pillars that we talked about earlier. So let's pick a couple. I'm going to pick reliability and security only for right now. We'll get into that. And we actually get a preview right off the bat of what questions it's going to ask us about our standpoint or our situation in our architecture with regard to reliability and security. And right off the bat, we're also being asked that first question. So what reliability targets and metrics have we defined for our application? Give us a little further description. And David, are there any of these that you think would be fun to zoom in on a little bit and talk about?
I think they're all kind of important. The one that stands out for me when I look at this list that I think is really cool, because again, it's one of those things people may not think about. It's the thing that says SLAs are service level agreements. And you could do other things besides SLAs, but for all internal and external dependencies. And for me, the cool thing is this is saying, oh, right, my reliability is often related to my dependencies. So let's say I want to have a reliability of I want to be up, 80% of the time, but I'm using some payment processor or some third-party system that says, oh, I'm only going to guarantee we're up 50% of the time, which, I'm just using round numbers. Hopefully you never subscribe to that service, the kind of up payment processor. But this gives us the notion that we should be paying attention to our dependencies because they roll up into our reliability. And for me, that's really great because maybe you didn't think of that. Maybe you did, maybe you didn't. But it's really nice to shine the little flashlight on things like that.
And maybe if you thought about it, you just thought about it. The idea of actually codifying it into a policy that's reflected in your own SLA is also important because we need to elevate that from the back of our mind. And that's true of a lot of these things. I think a lot of these things, as you go through, are things where you say, well, yeah, of course I know that. But when you see the list of a few hundred of these and you realize, okay, it's important to codify these things, it's important to get real crisp on them, then you realize that yeah, just always having in the back of my head is maybe not quite going to do the job.
Yeah, and I think that's Yeah, just writing this stuff down or having these conversations. And I saw that somebody asked this question, which I think we can sneak in here pretty easily, like which role or team in the organization should do this assessment?
Ooh.
And in my experience, it's going to vary on the topic. Like it may be the case that it could be anybody. You could be doing it alongside with your CSA, or if you have one, or and there it's anybody who cares about these things. But I think it's also really safe to say that there's not this expectation that you, person X, who is doing this particular review, knows everything about the reliability, security, cost optimization, and everything else in your organization. You might actually have to talk to other people, which is sometimes easy, sometimes harder. But like there isn't an expectation that everybody knows everything. So maybe other different pieces of your organization collaborate on some of these things, and wouldn't that be the best thing, right? Like isn't like talking to the other people and collaborating with other people in your org in theory a good thing? So like that's what I would say.
Yeah, I mean, I think it's almost certain to be the case. The likelihood that one person is going to sit down for some set of hours and be able to answer all these crisply without getting on Teams or getting on the phone or getting in a meeting with anyone else in the organization is pretty slim. Most of the time, this is going to be a group effort for everyone to kind of get together and decide how well are we handling these things? How well are we handling everything we need to?
I was going to say it also depends on your organization. If you're in a startup and there are 2 people, it might be you. like that would be reasonable. If you're in a very large organization, it probably isn't just you. Or if it is, you might want to check out the other people on your team. Are you trying to say we should move on to security?
We should probably talk a little bit about some of the other pillars, sir.
Oh yeah, well, wait, other pillars? You didn't say anything about other pillars. No, yeah. So
I know reliability is your favorite.
I love it. I love it. I can't get enough of it. But I also care about security. So let's go into security. So security is all about clouds with springs on them, right?
Absolutely.
Yeah. See, you can tell that some of these slides that come from the Learn module are more or less full of things to talk about, and so you'll see we'll go faster over them. So we talk about security, like we don't want to insult you. Like I am very aware that everybody who is watching this now and everybody who is not watching this now understands that security is probably important. And so we want to say a couple of things that are hopefully not entirely well known, like things that we're just telling you stuff you already know.
We're not going to try to talk down to you and say, hey, be protected.
Yeah. I mean, we want and because security, like everything else, is like this big thing. We're only going to really scratch the surface. And we're just talking about like, hey, congratulations, data is really important. And the thing to understand is that when we talk about data, we're not just talking about like your bank account, right? Right, like we're talking about privacy data. We're talking about the privacy of their data. And the example I give is, let's assume somewhere there's a domestic violence shelter out there that keeps track of its clients. Like if those clients are their address is exposed to their abusers, that can be like life-threatening, right? So it's really important to understand that we're talking not just about money. Sometimes we're really talking about privacy and safety, and that's where security comes into play. So,
and what do we have to secure?
We have to secure everything, but the only way that we know to do this, because there is no one congratulations, where's my magic wand, poof, we're secure sort of situation. The only way I'm aware to do that is to understand that there are threats at every sort of layer of what you're dealing with, right? And the only way to deal with this is is this defense in depth thing, which people may have heard of, which says, oh look, I'm going to care about these different security layers, and they're not all there. And in my experience, they're not all as cleanly clear in your environment as it says here.
Right. They're not really nested. They are blended and overlapped and puncture through each other, and are not so easy to make sure that everything is secure. We're not just putting a fence around each one, right?
Yeah.
It's not that easy.
Yeah, there's no moats. Like if you could just have a bunch of moats and you'd be done, that would be really awesome. But the thing is that this slide here is just meant to say, like, we recognize that every one of these layers, for lack of a better term, right? Like it's hard to know what else to call them, has their own common attacks on them, be it malware, be it code injection, be it denial of service attacks, be it, exposure of credentials, all the, like every single thing's got a thing. So, just be, I mean, this is going to sound like the old I forget what TV show it was, where, at the end, it was always like, yeah, and, okay, be careful out there, like is a thing. Stephen Bochco thing.
Was it Chips?
No, it was not Chips. That was very funny.
Hill Street Blues, maybe.
No,
we should move on.
Someone in the chat help us. Like, I think,
but doing a Stephen Bochco reference for security sort of makes sense, because those were all like and stuff. But so yeah, let's do a little scenario here, because just to start to talk about how that blending exists. So yeah, starting right at that bottom layer, for instance, if we have discussion about the physical layer, and in particular, when we talk about, hey, we adopted the cloud, so that's nice. We're now putting our stuff in a facility that isn't controlled by us. So Microsoft's handling the physical layer, but not entirely. Like, yes, that's great. Your actual hard drives are in a secure Microsoft facility, a secure Azure data center. So that and that's handled for you. But there's other aspects, right? Because yep, physical is handled. However, those hard drives store data that you let people get access to. Right. And if you're not doing a great job on identity, then someone could just either grab a laptop off of a cafe table, or they could draft into your building, sit down, and now, despite having great physical security for the actual data center, you didn't have good physical security for your office building or for your laptop, and you didn't have great identity, meaning you weren't handling passwords or biometrics well, or locking the screen. So all these things could still lead to leakage if we're not doing it in depth, if we're not handling things at every layer.
Yeah, and I think back to the time many moons ago, I used to work at a research lab, and the head of the lab was telling me about the time that he went to some company where they had everybody surrender all their laptops. Like, it was a secure facility, they surrendered all the laptops. But when they did that, when he handed over, he was asked, "So, sir, how much do you think this laptop is worth?" And at the time he reports, and this was a very long time ago, so this is even more money now, but he reports, oh, somewhere between $10 and $20 million would be my estimate, right? And that's, that's facetious, but it's true, right? Hill Street Blues. Yeah, sorry, our producer's been doing the thing. I really appreciate that other people knew that this thing that's in the back of my brain somewhere. So thank you very much.
David and I are old. We apologize.
I don't apologize for being old, because the alternative is worse, right, for us. So. Okay, but you wanted to say, I think on this slide, because I remember you adding this slide, because you wanted to say, like, hey, we are saying everything is bad and terrible, and you should just be very afraid. And I think this slide is meant to say, yes, that's true. We don't deny that, but we're here to help in some ways. And these are examples of helping. Do you want to say anything about that?
Sure. We already talked a little bit about, for instance, outsourcing some of your physical security concerns to Azure data centers. But when we think about that PaaS model, that platform as a service versus software as a service model that we talked about before, we can actually start outsourcing a lot more of these. Infrastructure as a service is a system where you aren't outsourcing very many, but when you get to the platform, or even software as a service, and I know we're kind of glossing over what those means, but platform means basically you can just run software on it, right? So when we think about that, we're thinking about things like app service. We're thinking about things like functions, right? You just run software on it.
Right.
And then software as a service is we just give you software. So Excel 365, right? Excel on the cloud, that's going to be your software as a service. So the more you move towards kind of outsourcing some of those concerns to Microsoft, because we're multi-cloud, Office 365 isn't Azure, we're a multi-cloud company. You outsource some of those to us, and you're going to worry less about them. Now, you're never completely absolved of responsibility for your own infrastructure, of course. But as David put it, we're here to help.
Yeah, and I think even it goes down to a small level. For example, we encrypt all of our storage, both at rest and in transit, right? You could be doing that for yourself as well, but we're paying really close attention to that and the security of that encryption and rotating the keys and doing that, all sorts of good stuff like that. I think it's really worthwhile that you understand how that all works. Is it important for you to do it personally? I don't know. You tell me. But would it be better if you let an entire team of people Microsoft hired pay attention to that? You get to make that choice. But I think one of the things that we can offer is, we're trying our best, just like you're trying your best, with the resources that we have to help you protect your data, right? And we want to offer as many of those resources to you as we can. Oh, I have another example, very brief example about that. One of the things that came up in something we did also about the Well-Architected Framework, which we did an event called Well-Architected the Backstage Tour, which you can go get, which you can watch on video, is there was a discussion about security. And one of the things that was cool about the security session that I want to mention here because it was so cool I can't stop talking about it, was we talked about how Microsoft takes in billions and billions and billions of security signals every day. And then it processes those, it does a bunch of cool stuff with machine learning, stuff like that. And then it creates a bunch of rules to help you detect problems or security issues. And we use those rules in our products. But it turns out we also dump those rules into a GitHub repo where you yourself can see them, can copy them, can modify them, can use them in a product like Azure Sentinel if you want. And so that's an example where it's honest to goodness shared responsibility, because you're telling us the things we need to know about security that we need to watch out for. We're giving you the best we know from the billions of people, billions of signals we get in from around the globe. So I think it's really important to understand that we can work together on this, and I know for a fact that we want to. So.
Absolutely. All right, let's roll on to cost optimization.
Money. Sorry, right? I'm sorry. We didn't. Did we? I hope we licensed that. Anyway.
Well, I didn't even hear what you started singing, to be honest with you.
Oh, I'm sorry. It's a really good song.
So I can't attest to whether it's licensed or not.
Yeah. Well, welcome to Microsoft Idol. Anyway, so welcome to cost optimization. We're going to talk about money. So what's cost optimization?
That's making everything as cheap as possible, right?
No. So you're just trying to goad me, and I appreciate
I
that.
am trying to goad you, yes.
Cost optimization is about ensuring that the money your organization spends is being used to the maximum effect. It is not about having the smallest or the cheapest Azure bill, because that could be zero, and clearly that's not useful for if you need resources and you don't pay for them and you don't got them, that's not good either. The idea is to make sure that you're trying to make things you're trying to get the most value for your money, right? There's ways to spend and get good value for your money, and there's ways to overspend or to spend in ways that don't give you your most value. And cost optimization is that process of figuring out, am I getting the most value for my money? And it shows up everywhere and all the other pillars and all the time. And this is kind of the balance, right? Like that sometimes these things cost, like to get more quality, speed, or efficiency, you have to spend more money. But the other thing to understand is sometimes if your thing is down because you didn't buy two of them and you're losing money, well, was that a good cost optimization, that saving of money? No, not so much, right?
Right. So 98% of the time you were running with two when you only needed one. But if the 2% of the time being down costs more than running that extra unnecessary server, then it was still a bad call to save the money, and should have still ran the redundancy.
I agree, but the thing that I think that we want to get to next is we want to make it clear that we say things like plan and estimate costs, right? Which is basically like isn't all that is pretty obvious, right? Plan and estimate costs. But I just want to sort of acknowledge that can be a lot more difficult than just saying that and showing a calculator, right? I want to acknowledge that, because one of the things that you'll find when you start doing cost optimization work that makes it tricky is that we have very different costing models for different resources. So examples are, we have a certain cost model for running a VM. So you run a VM, the longer, the size of the VM and how long it runs, that's how much money is. Unless you tell us, oh, I'm going to run this VM for 3 years and I would like cost savings, please, and you do a reserved instance, at which point that cost drops. Or maybe you're working with something that is by usage, something like functions as service, Azure Functions, right? Where every invocation of a function costs you a really, really, really tiny bit of money, but the more you have, the more you pay for. So that's one other model. And then there's these hybrid models like Cosmos DB, which is that giant database in the sky made out of alien technology. Sorry, I shouldn't be describing it this way. The Cosmos DB people would be really annoyed at me that I give away the alien part. But
they're advanced aliens, though. It's great.
No. Yeah, they didn't hear anything about it. Didn't do anything about. Sorry, nothing about aliens at all. What I wanted to say is that's a hybrid model, because not only in that situation, you have to realize that you're paying both the amount of storage you're using up and for resource units, which are ways of saying you're being charged for the work being done, the transactions that are taking place, and you have them at certain levels. And so I just want to say, when we say this stuff, I'm not trying to be Pollyanna and say, oh, just save money. Or
It's not just
estimate your costs.
It's not just balancing your checkbook.
That's
there's
right.
quite a bit more to it, and we know that. We're aware of that. But we also have to present this whole thing in an hour, so we might make it sound a little simple.
The good news is that there are tools that help with this. So one set of tools that we have that I think you can show a picture of if you happen to have one handy is of our cost our cost tools. Do you want to just flip? Yeah. Oh, I'm sorry. This is the thing that's not always easy, right? That's the not always easy slide. We should have probably said that during the
probably. There we go.
This is the picture I want to show. So this is the thing that I really dig about our stuff is that we do have pretty decent cost tools to help you figure this out. So this, to give you a sense of how much are you spending, where are you spending it, and what's our best guess as to what you're going to spend over time. And our best guess doesn't take into account your intent, which is why you have to participate in this process, why well-architected review stuff can be useful. Oh, that's a foreshadowing. Oops, sorry. Because, for example, we don't know, we, Azure and Microsoft don't know, oh, you always have this big, huge spike right on Black Friday, or maybe you have it on the day that, maybe you have this big spike on the day that some famous person like Jason or Kim Kardashian, like they have a TV show together, I don't know if you know, mention your product, on the ear, like on a Learn Live thing. And Jason says, I use this color, I use this type of shirt, and like everybody goes and buys that shirt, right? It happens all the time. We can't tell that in our cost models necessarily, but you can, and you can help figure that into your cost modeling. Oh, yeah. One of the places that people get a really easy hit when it comes to optimization, which is a reduction of cost, but also a good morning value, is to understand that it's possible to get rid of waste. It's not uncommon to find virtual machines that are running all the time, or maybe you leave your lab environment up over the weekend and nobody's around on the weekend, so why? Or people are keeping data on expensive storage when they could be using cheaper versions of that, or they're paying for license they don't have, or they're just rebuilding all the time when they don't have to, or whatever it is. There's lots of ways to reduce waste. That's one really good place. If you're looking for the one place to start, reducing waste can tend to be a really super good place to get a big bang for your buck.
And it's one that Azure Advisor is really good at helping with too.
Yeah. But I feel for some reason we have a demo.
Do you get that impression?
There's been a movement in the force.
You have
take it on.
Powerful with the force there.
Yeah.
All right. So now we're going to move on here, and we're going to look at the security pillar, which is one of the pillars we just talked about, but we're going to do it in a particular light, because we're going to look at one of these checkboxes that I moved past in our first review. We're going to talk about our new workload-specific reviews. Now, this is really cool, and as you can see, Azure Machine Learning is our first one, but we've got more workload-specific reviews coming out. And the great thing about these is because we're asking you, what are you doing? What particular types of applications are you running? What particular types of services are you using? We're able to make the questions and the resulting guidance, hint, hint, that's coming up later, be a lot more on point, be a lot more specific to those services and those setups that you have. So this is the first one. We're going to take a quick look at what we can get out of that more specific treatment. So let's actually hit security specifically. And so we can see this is all about Azure Machine Learning. So what design considerations did we make in our workload with regards to security for Azure Machine Learning? So we've got things about MLOps. We've got things about the Azure Machine Learning security baseline. So these are very specific to that workload. So Azure Machine Learning security baseline is a unique and specific baseline to your workloads that involve ML. So this is specific. This is not just the general guidance saying, hey, are you using Azure Security Baseline? No. This is about the guidance specifically there for machine learning workloads. And then same thing when we come here, we're saying, okay, what are our governance policies? And if we don't agree that we've actually reviewed and implemented these machine learning specific policies, we're going to get a link in our guidance. I may be foreshadowing a little too much. That's going to be exactly specifically about machine learning and getting a proper governance policy around that. And that's going to be specific to things like responsible AI, making sure you're doing the right things and the smart things with your AI so you're not doing things like having irresponsible use of facial recognition or biased use of facial recognition, or many of the other interesting services. You know, we have neural voice and things like this that could be misused if A, Microsoft wasn't diligent, but we are, so not everyone can use custom neural voices, and B, if you weren't diligent. So we want to make sure that you are being, and we're helping you out with very specific guidance along those lines. And that's going to, in addition to just making you better corporate citizens, it's going to also help reduce your exposure to things like lawsuits or just bad publicity that would come from bad ML usage.
I think the thing, I guess there are two things I want to say that I think are super useful about what you're saying. Thing number one, I want to say that's really useful is to understand that, as Tolstoy said in Anna Karenina, right? Every family is happy in the same way, and every family is miserable in its own unique way. And the thing that I really like about the fact that we're doing workload specific things is we acknowledge that ML workloads have particular characteristics. They have things that are you have to pay attention for just them, and we try to make sure that we ask you about those. The other thing I want to mention that I think we didn't mention before that's useful to know is you don't get penalized for not answering questions. If like there's an entire section you're like, yeah, I don't know anything about that, or I haven't dealt with that before, you can just leave that out and it will be just fine. Like this isn't like, you know, so I think that we should, you know, you should just know this as we get there. But I think my sense is we probably should get back to pillars, right?
Absolutely, sir. How about operational excellence?
Yeah, this is another place where we could talk forever and ever and ever on. Let's try not to talk forever and ever on it. Jason and I have some theory, we've had discussions about what is operational excellence. One thing suggests mind, or you know, whatever suggests. It's about making sure that you're really intentional about the operational concerns that show up everywhere. Are you paying attention to how you're releasing software? Are you paying attention to how you're instrumenting things and setting up your monitoring and your observability stack? Are you paying attention to how you're getting rid of it when you're done? And so one thing you can do is you can draw upon modern operations practices. Specifically, I'm talking about DevOps and site reliability engineering here. This is a picture from our DevOps tool doing pipelines. You should pay attention to those. You don't have to do those things, as you don't have to become one of those things. You don't have to become a whatever a DevOps thing is, like a DevOps engineer or something, if that's a thing. Or
I don't know. I've heard people just call it a DevOps, which I really don't like that term. But.
Yeah, whatever those things are. You don't have to become a dev. Yeah. Anyway, let's not go into that thing because that'll get even farther off track. But right. but you can take some of the practices from these modern operations practices and incorporate them, and you'll find that they will be useful to you even if you don't have anybody with that title on staff. Right, it's super useful, and I hammer home on this notion that you really want to pay attention to monitoring analytics because, quite frankly, you'd like to know whether things are getting better or they're getting worse, and it comes through all parts of your. If your monitoring or observability isn't good, lots and lots and lots of parts of what you're trying to do for a living will fail. When things go wrong, when you're trying to debug your software, when you're trying to just develop it. So you really want to spend a lot of time paying attention to that.
It's like we talked about before, getting data driven. Now, of course, you have to get something up there to get data driven, but you get it up there, then we use our monitoring and analytics tools to get the data. And then we can start getting ourselves in the direction we want to be, both in terms of our reliability, our performance, and basically all of the things that we try to optimize towards, even our cost, right? Once we have better tooling, we can even get better about better tooling, better operational behaviors. We can get better about managing our costs as well.
Yep, and I'm going to squeak in something before I talk about automation. It looked like somebody mentioned that, you know, we're seeing various things in the chat. Somebody asked, are we getting an idea of the result of the demo? Oh, we are definitely teasing you all the way to the end, but we will for sure, I promise you, show you what happens when you actually run through the well-architected review. I promise, and you'll be
even if we have to talk faster to do it.
Yeah, you'll be so happy when you see it. Okay, automation, I just want to say, like, here's the deal. We understand that automate everything is not necessarily the greatest goal, but having an understanding that you can automate things allows you to scale non-linearly. It doesn't mean that you have to throw more people at the problem if the people can do things smarter and have the computers do some of this stuff. It's really kind of understanding that you can sort of reduce toil. And toil is something very specific in site reliability engineering. It's referring to things that are manual, that are repetitive, that are often automatable, that are tactical and not strategic. But even better, the thing that I like to talk about toil is that there are things that have no lasting value. So like you did that thing that added 100 people to it. The system isn't any more reliable, secure, or cost or whatever. It's just running, right? It's an overhead, right? And if you have 1,000 accounts to make, that's going to take you 10 times as long. That doesn't scale linearly. So that's where automation is really super important. And, give or take, JSON on the, I think, did you put the JSON on the slide, Jason? Because
I'm just glad it's JSON and not YAML. That's all.
I see. Well, yeah, right. Yeah, well, we're trying not to cause any people problems. Oh, and the thing that also comes up when it comes to operational excellence that we like to talk about is that testing is super, super, super important. But we're not just talking about the kind of testing that I think people think about when we're in the middle of operational excellence, like the DevOps stuff, right? That's like the dev tests, right? The unit tests, the integration tests, and that sort of stuff. Like there's more to testing. And we're going to just point out a couple of those. One of them is round trip testing, which I guess could be part of your other testing regimen where you're actually running something through the system all the way, not just like doing the parts to see what your customers experience, right? Yep. That's going back to the customer experience. There's penetration testing and other security testing where you're making sure that things are as secure as you think they are. There's fault injection where you intentionally put faults into the system to see how it's going to happen. There's disaster recovery, which people don't often test. They're like, oh, I set up my DR system and they never test it.
I've got a backup somewhere. I don't even know where it's at, but we're backing up.
Oh, I don't think it has to be. It's not always that rough. Sometimes it's just like, yeah, we set up DR, but we don't really test it. We tested it once when we set it up, sort of thing. And then the other cool thing, and I really dig a lot, and I would love to talk more about, but I know we're not going to have enough time, is chaos engineering. That's the process of doing basically scientific experiments to find out what your systems and workloads will do under the turbulent conditions of production, right? The things you don't know about how your system is going to respond will be things that the internet will show you for you, or you can find them out first, right? And it's so much more fun to find out first, to do these experiments yourself. And if you're into the chaos engineering stuff, I want to say that one very cool thing, and I'm excited about it, is that we went public preview on the first Microsoft Azure chaos engineering platform called Chaos Studio. We just announced it. You can find it elsewhere, and I know we're going to be talking about it. I'm super psyched for this stuff because I think chaos engineering as an operations professional is one of the coolest things I saw happen in the last 10 years or however long it's been along, and it's really been thrilling. So do check out Chaos Studio for sure. There's the blog entries and stuff. Check it out because it's really cool. It's powerful. It's potentially dangerous if you don't use it for in the right way. But with great power comes great responsibility, and it's cool. Okay, shall we hit the very final pillar here? Because that would make me very happy if we did.
Performance. What is performance?
Well,
all sorts of things.
Yeah, well, I'm pretty sure it doesn't mean to go fast. It means lots of things, right? And it even means things that we're not going to talk about, because some of these things on this list are sort of scaling-esque sort of questions. Can I scale? Am I performant? But to understand that performance has got things around benchmarks, it's got things about optimization. There's lots of stuff to performance. We're just going to cover one kind of sort of part of that. This is your slide. I like it a lot. Would you speak to this for me?
So I want to focus on when we talk about our pillars, we're not actually talking about performance. We're talking about performance efficiency. So this is actually the kind of architectural principle that we're caring about. We can get performance in various ways. For instance, writing faster, more efficient code, or adding more servers, which we'll talk a little bit about. But performance efficiency specifically focuses on the fact that we don't want to over allocate, as you can see in that top box right here. All right, so I've over allocated, I've just got a lot going on. Here I've under allocated, which means sometimes I'm getting performance hits. Now, without the ability to just allocate on the fly as demand changes, we are stuck with picking one of these two. And remember, it's appropriateness that matters. So we're not just going to say, oh, well, obviously we're going to have to do this one. Sometimes a small amount of performance degradation at the right time, given other trade-offs, might be the right thing. But one of the things that I'm sure y'all realize about the cloud is that we get to increase performance we get to increase our available resources a lot more nimbly on demand compared to if we just had to buy servers every time we were changing our demand forecast. We can obviously do it a lot more nimbly. Speaking of buying more servers, We
Well,
can
so
talk
yeah,
about.
I mean that's like, so you don't have to have a pallet of servers be backed up at your loading dock, which I've racked and stacked well, there are two ways people think about when they're talking about scaling, especially when it comes to performance. They're talking about scaling up, which is buy the bigger one, which is sometimes really important when you can't do anything else. But that will run out at a certain point, because you can't buy. Sometimes you can't buy something that is a single thing that is big enough to hold what you need. Often then you get into the land of more horizontal scaling. That would be vertical scaling. Horizontal scaling, where you split up your workload amongst a bunch of smaller things, and you can have a bunch of them. I see Tinkerbell is showing us the second part of the slide. Thank you for that. So I just want to say one thing quickly about the previous one, very, very briefly. The thing to understand is that when you talk about horizontal scaling, the application has to be built with that in mind. It isn't the case that you can all of a sudden start running your accounts payable system. You can run 2 of them or 4 of them, and if they're not built for that, they're going to start to fight and they're going to corrupt your data, and that's like a highway to heck, like for sure.
And it's one of the things you need to really test when you decide that you're targeting horizontal scaling. Is
you can't just sprinkle horizontal scaling out on stuff and expect it to work like Pixie does. The other thing you have to pay attention to when it comes to performance is often, as we build stuff out with now smaller components that have to talk to each other, or we're concerned about where our customers are actually connecting into our systems. Maybe we care about network performance, and something we haven't always had to think about when we were in the data center before, when there was a single data center. So this is something we pay attention to. Also, because you can make choices about what you're doing when it comes to storage, you can choose amongst the different kinds of things, and so we might pay attention to the traffic patterns. Is it mostly write? Is it mostly read? What am I going to do based on what you're going to order from us, right? And that would be a thing to optimize for sure.
All right, let's just quickly touch on the fact that we have ways. We have our application insights right here to help you monitor these things and help you look for the places where you can optimize. But to Robert's question earlier, let's go ahead and get to that review again, shall we? All right, we want to see the output of our review. So after we've gone through a bunch of questions, we're going to come here and be told, well, in my case, I have a lot of room to improve. So that means that I said, nope, I'm not doing several important things. You can see I actually didn't focus too much on answering a lot of questions in these pillars, but here I did some interesting things. So if we look, for instance, actually, let's focus on security. Let's go down to the security. It's going to scroll us down. I have a lot of recommended actions. Now, a lot of these here are based on the questions and answers that I had when I went through our questionnaire. If I actually, since I answered no, I'm not doing those to so many, I have a lot of those. But if I scroll down until I see this cool little icon right here, this lets me know this is actually because I tied my assessment in to our Azure Advisor system. So now I can actually integrate these two things and sort of get a single picture of what I need to start working on. And so here, if I were to click on one of these, that's actually going to bring me right up to Azure Advisor and literally to this screen. And the only reason I'm not clicking it to bring up the screen is because I'm a little worried it's going to reveal subscription details. So I'll just have that pre-opened for us, and now we can jump over to it, and it's going to bring me right here. And so here, my security screen has the recommendations on what I should do.
Ooh, look at that button. Look at that button.
That's a button right there. Yeah, isn't that cool? So Azure Advisor is actually looking at all of the services I have deployed, all the settings I have deployed, and it's recommending things I can do better and should do better. And in some cases, boom, I can just hit a button and it will solve it for me. So this is super cool. I can also come back here and I can look at any of these, and any of these links are going to bring me to a very specific docs article letting me know how to handle fixing that problem. So we've got some amazing specific links, both based on what Azure has seen in our environment, as well as what we answered about our environment. So the things that Azure can detect for us and the things that we have to tell Azure, both are covered, both are handled, and we get that one snapshot of things we need to do to start improving.
Can I also say one other thing? When you said tying it into Advisor, that's as simple as logging in, right? When you signed in, it's going to help tie it to. It's not like it's an extensive process of click here, run this PowerShell here, do that. It will just pull it in if it knows who you are. Yeah, I think that's really useful.
Yeah, if you guys, if you all recall at the very beginning, I said, hey, there's where I could log in with my portal credentials and therefore tie it into the Azure Advisor. So the Azure Advisor is always there and available, but having it wrapped into the assessment gives us that one-stop shop.
Can I show one other cool thing I don't think people may have noticed on the results page?
All right, let's go.
Very briefly, if you would just pop back to one of the results pages, wherever it is. So the thing, stop, up, scroll up a little bit, up, stop there. So see that little link over there that says export to CSV? One of the cool things that you can do is you can export the results of your recommendations of this to a CSV file where you can do a number of things. You can use that as the basis of importing that into Azure DevOps. So you have a bunch of work items. You can do it, with some tools that we provide, turn that into a PowerPoint to have a conversation with your team about your recommendations. So you can do this. There's a lot of stuff that you can suck that you don't have to be in this tool to get value out of the recommendations we have there. You can make a checklist out of this. It's just really cool. And I don't think people notice that little link over there nearly as often as I wish they would. So. Yeah,
fantastic. And we did have a question from Andy. Do we have to rerun the assessment to update Azure Monitor? I think we mean Azure Advisor, or are the results dynamic? So Azure Advisor is always running in the background, and it will always grab the right results for you.
Yeah, and if you want to know more about Azure Advisor, not to shill a video series that I've been in, but I will. Like, there's a whole video series called the Azure Enablement Show, and in there we do, and you can easily look up, Azure Enablement Show. You can find in the well-architected ones some advisors ones in which we talk about how often they refresh, what you might want to know about them, and some other cool details. Well, I think we're heading towards the end. I'm hoping that we did the things on the previous slide, which is we talked about well-architected. We told you how to use it in your environment, and we gave you some architectural things. And now it's up to you, young Padawan, to go from here. How do they do that, Jason?
We might not have the licensing for that either.
Oh, yeah. Darn.
All right. So to take your own assessment, aka.ms/WAF will actually take you to our Well-Architected Framework guidance, which is actually our specific documentation about complying with the well-architected principles, and has links to the assessment.
And learning about them, yeah.
The assessment itself, we can find it aka.ms/assessments. And we can also check out more about Learn Live. You guys may have seen some of those cool Learn Live shows. They're pretty great.
And more about he's being modest. I just want to be clear about this. He runs them too.
All right, folks. Also, don't forget to do more with our Ignite, our fun Ignite stuff in our various landing zones there for Ignite, Cloud Skills Challenge, more Learn at Ignite. Bye for now.
Yeah, and if you want to check us out, by the way, we have our Twitter handles right there, and you should, if you definitely follow Jason. Jason wants those. But I'm hoping that you come talk to us about Well-Architected, because we don't want to stop this. We know there's so much to talk about. Thank you for your participation in the chat. Thank you for watching us, and continue, rock on is what I want to say.